Okay, here we go again. We are going to keep tackling these trig functions. And again, I highly recommend starting by rewriting everything in terms of sine and cosine. So this first one, secant, I'm going to rewrite as 1 over cosine x. And then I'm going to write divided by, again, because I'm seeing multiple fractions, things happen here. It's just going to get a little ugly. So divided by sine of x. So I'm going to put sine x over 1 just for my peace of mind here. Then I'm going to subtract secant again. So this is again 1 over cosine x divided by cosecant, which is then 1 over sine x. Okay, so invert and multiply on this first one. We're going to get 1 over cosine x times 1 over sine x. This is going to subtract everything over here. And this, we're going to get 1 over cosine x times sine x over 1. Okay, so on the left, we get 1 over cosine x, sine x. And then on the right, we get sine x over cosine x. All right, in order to do this subtraction problem, we need a common denominator. So I'm going to multiply by 1. And the 1 that I'm choosing to multiply is going to be sine x over sine x, because then my denominator will be the same on both sides. So now we have 1 minus sine squared x on the top divided by, when we subtract, the denominator stays the same. So now we have a common denominator of cosine x, sine x. Well, again, this top part should kind of be singing out to you as special because this is just our trig identity. So this is cosine squared x is the same as 1 minus sine squared x. And again, that's on the sheet that should be in front of you as you work on these until you get comfortable. Over cosine x, sine x. Well, one of these cosines is going to cancel out, and we're left with cosine x over sine x. Well, we want a singular trig function, so we're going to convert that, just to cotangent of x, because cotangent is cosine over sine. Theta, of course, involved. All right, this next one, same idea. We want to tackle these pieces and separate them into sine and cosine. So again, secant is going to become 1 over cosine theta minus, I'm going to put cosine theta over 1. Again, I'm going to have to get a common denominator, deal with that whole business. And then divided by everything that's happening over here, sine squared theta, I'm just going to leave alone for now. And it's being multiplied by secant squared theta. And we know that secant squared theta is the same as 1 over cosine squared theta. All right, we can put this over 1 as well. Okay, so we are subtracting here, so we need a common denominator. So we need this to be cosine theta in the denominator. So I have to multiply by cosine theta over cosine theta. So on the left, we're going to have 1 minus cosine squared theta all over cosine theta. We had a common denominator, and then these two became squared. And then this is all being divided by this business, which is going to simplify when I multiply across the top, multiply across the bottom to sine squared theta over cosine squared theta. All right, we're going to invert and multiply. Also, actually, let's think about this as well before we invert and multiply. This should be ringing bells because, again, it looks really a lot like that trig identity we have, and that is sine squared theta. So now we have sine squared theta over cosine theta times, when we invert and multiply, cosine squared theta over sine squared theta. Well, these are going to cancel out because when we multiply across the top, multiply across the bottom, we're just taking sine squared theta and dividing by sine squared theta. So those are going to cancel. And then one of my cosines is going to cancel as well, and I'm just left with cosine theta. as my numerator, which is my singular trig function. Okay, next one says we are to completely simplify this trig expression here. It looks a little scary, but the strategy is exactly the same as it has been on these last ones. So we're just going to start by rewriting. So 1 plus, instead of secant, I'm going to write 1 over cosine theta. And again, I'm going to do divided by. Rewriting secant is going to again be 1 over cosine theta. And minus 1, we're just going to leave as minus 1 for now. This is the left-hand side. There's a lot going on here, so I'm probably going to deal with this and then the right-hand side separately. But let's get it ready anyway. 1 plus cosine theta over, well, let's get in the principle of just doing divided by cosine theta minus 1. Now, none of those needed to be rewritten, so we're really going to focus on the left-hand side to start with. First things first, if I want to add these together, I need a common denominator, so we need cosine theta over cosine theta to replace my 1 here. And same thing over here, this is going to be cosine theta over cosine theta instead of 1. Okay, so we get cosine theta plus 1 on the top over cosine theta, right? Because common denominator just stays. And then this is all being divided by 1 minus cosine theta all over cosine theta. Okay, again, we're just focusing on the left-hand side here. The right-hand side is still to be dealt with over there. So we're going to invert and multiply. Cosine theta plus 1 over cosine theta times cosine theta over 1 minus cosine theta. Cosines cancel out, and we get cosine theta plus 1 over 1 minus cosine theta. Those are not the same, so we cannot cancel those things out. All right, so now let's deal with the right-hand side, because then we're going to have to add them together and do all of that. Okay, so I have 1 plus cosine theta being divided by cosine theta minus 1. If I take a negative 1 out of both of those, I can kind of rewrite this in a way that makes sense. So if we leave the top, all right, actually, I am going to write this as a fraction so you can kind of see what's happening here. If we leave this like this, right? So we are doing a division problem here. What I'm suggesting is that we factor out a negative 1 and rearrange this thing so that it looks a lot more similar. So essentially, if I factor out a negative 1 or multiply by a negative 1, however you want to think about it, the top becomes negative 1 minus cosine theta. And the bottom becomes, becomes negative cosine theta plus 1. Okay, and now I want to rearrange these so that it looks the same, so that we have the 1 and the cosine in the same spot, right? So if I leave negative 1 minus cosine theta on the top, I just want to rearrange this so that it's 1 minus cosine theta on the bottom. See how that works there? All right, well, if we do that, that's just, well, let's tackle that with the left-hand side still. We want to combine these two things together. We want to add them, right? So we still have this addition that was happening up here, and we need to then add both these sides together. Well, highly conveniently, they already have the same denominator, so now I just need to add the top. So we get cosine theta minus cosine theta. Well, those two things are going to cancel each other out, right? Cosine theta minus cosine theta is just 0. And then we have positive 1 and negative 1, so those cancel out as well. So on the top, I have 0. On the bottom, I have 1 minus cosine theta. Well, what is 0 divided by anything? Just 0. So this actually simplifies all the way down to 0. And notice they said simplify the trig expression. They didn't say write it as a singular or anything like that. So it's fully possible that we get something like 0 in the end, which is what we got. All right, you're going to give the next set a try, and the answer key is posted so that you can check your work.